You've got essentially 5 sets of electrical devices and appliances that take up that, and that's your refrigerator, your washer and dryer, the lights in your home, and your HVAC, your heating, ventilation, and cooling. And these things are actually the large consumers of energy, and kind of the common thread about it is that none of them are intelligent. And so what we'd like to do is we would actually like to have the capability to be able to detect these devices being turned on and off. Now, if they're intelligent, you'll be able to tell the home energy panel or home energy management system that, hey, I turned on and I'm using this much power. But unfortunately, that's not the case today. Your refrigerator isn't going to say, hey, I turned on, right, to your computer. So what we're doing is that we're researching how we can detect through inference of that refrigerator being turned on. Now today, if you want to measure energy, you would need to buy some sort of device, and in my panel I actually have a circuit breaker, but you would have to actually take out the metal casing, expose your 200 amp service, and then you have to put 2 current transformers. This is kind of a larger current transformer, but you would have to put around these thick wires about this thick, and put it around and then hook it up, and trust me, that's not something you really want to do, because that's 200 amps of service. It could be very dangerous. So you would probably have to hire an electrician. They would have to have a truck roll come to your house, $200 for them to come, $200 for the labor, and $400, boom, you've got something that will actually measure your energy for your whole house. What our device does is it actually tells you precisely what device turns on and off and how much energy you're using, and I'll show you a quick demonstration of that right now. Okay, so this is the actual device right here, and as you can see, I don't have any current transformer or any of those devices plugged in. All I have is I have it just plugged into an outlet. So you would just have this device, plug it into an outlet, maybe one that's close to your in your garage, or actually you can put it anywhere you want, but it's just a plug-in device. You don't have to open up anything, you don't have to do anything dangerous. It just plugs right in, and it self-configures itself and to your home environment. And then I'm going to turn this on here. And then so I've got this toaster, and I'll go ahead and I'll turn it on. And it didn't detect. Let's try it again. I must have gotten some other interference. There it goes. And it tells you how much power it's using, and this is an accumulation of how much energy you're using with this toaster on. Turn that off. It detected that. I can also detect like a hairdryer. This is actually kind of like a furnace, and because it's got a blower, it's got a heater, so it's got some of those characteristics. So this has a completely different electrical characteristic, and again, we read this from an electrical, from the electrical characteristic that happens. So we'll go ahead and turn this on. Touch the toaster, sorry. Let's try this again.
A couple of years ago.
Oh, just thinks it's a... Okay, I'm getting too much interference probably from some other things. Let's try one more time. And there's the hairdryer. And actually, at the same time, I'll turn on this light. I detected the light. And I'll turn this off. There we go. And so even though you have these same devices turning on and off simultaneously or on top of each other, this is still able to differentiate, because these two devices have different electrical characteristics. A refrigerator has a blower that turns on, and then a compressor that turns on a certain increment of time afterwards. A microwave has a light bulb and a fan that turns on, and then it charges up a magnetron. And again, it has a very unique signature and characteristic, and we're able to look at those signals and discern the different appliances being turned on and off.
And it just has to be plugged in one place in the house, not necessarily in the same strip? Just
Yes.
one place in the whole house?
Yes. Well, so actually, I'm going to get a little technical, but in your home, from your utility, you get 220 volt service. It gets split into two, and there's actually enough isolation between these two phases that you actually need to have these devices plugged into both phases. So it's just, so you can plug this in and it'll turn green, and then you plug in the other device, and if it's red, that means that they're all in the same phase. So just plug into another plug in your house, and when it turns green, then you've got your whole house characterized. And then going back to your question, really the challenge of adding a solar or photovoltaic device is that you have to be able to measure, and you have to manage intelligently and take care of kind of all the back-end plumbing to make these things work and to work intelligently. And so now we've got this capability where we're beginning to measure how much energy you're using totally, and how much energy will your PV provide, your solar device. And so by providing all this information and then back to some home energy management system, then you have the control to decide what you want to do in your house. And for an example, as Lori mentioned before, really the utilities, their challenge is to reduce the peak usage, because really the utilities are during the day it's about 30% utilize the energy, but then when everyone comes home on a hot summer day, then the peak usage rises, and if it goes beyond a certain amount, then that's when they have to provide new generators or new dirty power plants. Now if they can reduce the peak usage, then they don't have to build these new power plants, etc., and they save money in turn. Well, let's say what the utility, their motivation would, they would probably want to have the control to turn off your AC unit, during the summertime. Well, why not instead you provide, data, anonymized data to the, the utility companies that you choose, and you can opt in whether or not, and they would give you some sort of monetary incentive to say, hey, if you turn off your AC, then we'll give you this rebate, and you can tell your home management system, hey, I like these kinds of rebates, I'll do that. So again, it goes back to empowering the end user, empowering the consumer to make those choices rather than have the utility
Definitely.
make those choices for you.
What are the options for managing the peak usage, other than people opting in?
Yeah. So today, how I guess things work is that there's something called a Public Utility Commission, and what they do is that they are a government organization, and they tell the utilities, whether they're private or public, that you can make this much money, you can charge the customers this much. So they're kind of a managed monopoly. And so that's and actually the Northwest Utility Commission, the PUC, they said no more new power plants. All new energy is going to be from conservation, and so that's why you have the utilities, providing you rebates for compact fluorescent bulbs and things like that.
But what are the new ways to produce energy? It's just not using it, not producing it?
New ecological ways, replacing your incandescent bulbs with CFLs. So they're not really hard measurable programs, but they're kind of these marketing programs that they hope will reduce the amount of energy that people will use.
And then so managing at peak times is just getting people not to use so much.
Yeah, at specific times.
Okay,
Yeah.
that makes sense.
Yeah.
How do you get the electronic signatures for these? Is it from a profile that you create, or is it something that comes from a database that
Yes.
perhaps Intel provides? Or?
Yeah, so that's a great question. So we're actually working with some appliance manufacturers, and you could easily turn this into like a crowdsourcing type of application where people go onto the web and they say, oh, this is my device, this is the model number, and this is the electrical characteristic, because I have this device here that detected something, and I know that it was my Conair white hairdryer. And then it would provide the specific electrical signature and of that device, and it would be stored, and it would be compared against other people's as well. And what this device also does is that it automatically calibrates itself because people have a diversity of electrical systems in their house. They're all different, and they all have different characteristics. Well, this actually is able to adapt itself and essentially sends out a signal and says, oh, you've got this type of system, and I understand, and I need to look for these types of signatures.